All right, make sure this is last week before Christmas break. Make sure that you have taken test 3 first. When you're ready to take test 3, shoot me an email. Let me know that you want to take it. I'll send it to you and you can get it done and send it back. Then we're going to start chapter 4. And in chapter 4, we begin by looking at what we call a system of equations. A system of equations is when you get two or more equations within the same grouping. And we have in chapter 2 looked at how to graph an equation. Well, now you're going to get a system which is going to include two. Now systems can be bigger than that. We could have 3 or 4 equations on this or even more, but we're going to stick with 2 equations within the same system. And when we're looking for a solution for this system, we're looking for the ordered pair that can be plugged into both equations and make them true. So there's going to be one common point that can fit into both equations, and we want to find what that point is. And there's different ways for doing that. The first method for doing that is by graphing. So we're going to take each one of these equations and we're going to look at them on the graph. Okay, this is in slope-intercept form, so it's really simple to graph. My y-intercept is -2, so it's going to cross the y-axis down here at -2. That's where my first point goes. And then I'm going to use the slope, the rise over the run. It's going to rise 1, and it's going to run 2. Rise 1 and run 2. And I'm going to draw that line. Again, I would use your ID card on your computer to draw a straight, as straight a line as you can, because there's going to be a little bit of error if you're drawing your own graphs. So we want to be as accurate as possible. Okay, when I go to graph the second line, I'm going to graph this second line on the same graph. Okay, I'm going to change my color up here. Let's go purple. Okay, when I graph this line, it has a y-intercept of -7. So it's going to cross the y-axis down here. And it has a slope of 3. Now I can make this into a fraction by putting a 1 under it. So the rise is 3 and the run is 1. So I'm going to rise 3, run 1. And I'm going to draw that line. Okay, that is not a very straight line. But I can't put a straight edge up on here or I'll lose the whole thing. But anyway, this is basically what your 2 equations are going to look like. And we are looking for the solution for this system. We're looking at the one point that I could plug into both equations and it would be true. When you look at that graph, where do you think that point would be? Okay, hopefully you said that point's going to be where the 2 lines cross or where they intersect. Okay, so I'm going to go back here and say right there, okay, where they intersect each other. That is my solution. So what would that point be? It looks like it's at +2, -1 is where that point is. So the solution to this system is 2, -1. Now how could I check that to make sure that it works? Okay, hopefully you said plug it in. Okay, if I take this as my x value and this is my y value, if I plug that into the top equation, 1/2 times 2 is 1. -2, I do get a -1, so that works in the top equation. And if I plug it into the bottom equation, 3 times 2 is 6, -7, I also get a -1. So 2, -1 is the solution to that system. Okay, let's try another one. Okay, I'm going to give you, I think that's pretty self-explanatory, so rather than doing those, there's a couple of unique situations that we're going to look at here. Y equals 1/2 x plus 7, and I might have 4x minus 8y equals 12. Okay, when you get a system, you're not always going to have them in slope-intercept form. Okay, the top one is in slope-intercept form, but the bottom one is not. There are different ways to graph a line. We could find intercepts here if I wanted to. So if I wanted to find, since this is standard form, if I wanted to find the intercepts, I could put a 0 in for x. That means that's going to drop out. And if I solved that, I would be dividing both sides by the -8. 12 over a -8 is going to come out to a -3/2. Okay, so that's 1. intercept, 0, negative 3 over 2, or that's negative 1.5. Okay, if I put a 0 in for y, if I put a 0 in for y, I'm going to cover that up because that would be 0 and that would drop out. If I divide both sides by 4, I get a value of 3. So one other way, rather if you don't have slope-intercept form, one other way that you could find or graph the line is to find the intercepts. You could also make a table of values. Or you can take this equation and you can put it into slope-intercept form. Okay, I'm going to go ahead and draw a graph. Okay, so there's my graph. If I'm going to plot or graph this top line out of the equation, I'm going to start at a positive 7. So we up here. And my slope is 1/2. Now if I rise 1 and run 2, I'm going to quickly go off my graph here. So I could take that slope and I could make both values negative because a negative divided by a negative is still positive. So from that y-intercept, I could actually go down 1 and then I'd go left 2 just to keep me on my line there. Okay, so there's the line for the top equation. I'm going to go ahead and switch colors again. Okay, as I go to graph the second line, I'm going to use the intercepts that I just found. So 0, negative 1.5 is right here. And then 3, 0 is right here. Okay, and what do you think those lines look like? Where are those lines going to cross? Actually, if you said those lines look parallel, they're not going to intersect. That's a situation that we come across. So rather than example 1, where we saw the lines intersect, we had one single solution where they crossed. Here's an example of where we have parallel lines. And so we would have to answer this and say, our answer is no solution. There's no solution to that equation. Those lines do not cross. And that will happen to you as well. There's no x and y value I could plug in that would make the top equation true. That would also make the second equation true as well. So that's a situation that is a no solution. Okay, and then I want to look at one other possibility that you might run into. And it says 3x plus 2y equals 9 and 2/3 y equals 3 minus x. Okay, this top equation is in standard form. I would probably find intercepts to graph that. Let me go over here and let me do that. This way so that the graph is black. Right? If I want to find the intercepts here, I would be putting a 0 in for the x. If I put a 0 in here, 3 times 0 is going to drop out. If I divide both sides by 2, 9 over 2 is 4.5. Okay, or 4.5. Okay, and then if I put a 0 in for y, put a 0 in over here, that's going to drop out. If I divide both sides by 3, I'm going to get 3. Okay, so 3, 0, and then 0, 4.5. Okay, this is kind of messy. I don't really like that. So I want to get y by itself. I'm going to put this in slope-intercept form. So how do I get rid of the fraction in front of y? Okay, I'm going to multiply that by its reciprocal. Take it times 3 over 2, and if I do that, I have to go to the other side and multiply by 3 over 2 as well. So I would now have, this would be 6 over 6, which is 1y equals, you're going to have to distribute here. So you're going to get 9 over 2 minus 3 halves x. And I'm going to flip those around just so that this is in slope-intercept form. We have the x term first. Okay, so if I go to plot, if I'm going to graph the first one, I'm going to graph that in red. So 0, 4.5, 1, 2, 3, 4.5 would be right there. And it's also going to go through 3, 0 down here. So my line looks like this for the top equation. And the bottom equation, I'm going to graph that out of slope-intercept form. So 9 over 2, that's the same thing right there. That's 4.5. 1, 2, 3. So it has the same y-intercept. And then if I go rise over run here, I'm going to go down 3 and to the right 2. So 1, 2, 3, 1, 2. Look at that. I'm right on the line. Okay. Each time you go down 3 and over 2, you're going to end up on that same line. So these two equations are actually the same line that you have. And when those two lines are touching everywhere, we say that this has an infinite solution. Infinite solutions. Okay, so the two lines actually graph right on top of each other. They're the exact same line. We would answer the question and say we have infinite solutions there. Okay, give worksheet 401 a shot, and if you have questions, join the Zoom meeting. Even if you don't have questions, join the Zoom meeting so I can talk to you and make sure that you're on the right track. All right, see you later.